this computer.
Okay, so I will start and share my screen. So, can you see my presentation now?
Perfect, super. Now we can start. We can go live.
Perfect.
We are welcome again with expert Sandra Balnik from Litos, pioneers in the 3D printing of ceramic. There is a lot of updated in the ceramic material and in the technology that we will share with Sandra about the new updates of the future of 3D printing of ceramic. The stage is for you now.
Thank you. So thank you for having me today. Yeah, thank you for a nice introduction as well. Today I will tell you something about our technology, so the LCM technology from Litos, and also our solutions and applications in the medical and dental 3D printing, and also the newest developments and the newest technology things we did. So let's start. Short overview about Litos. We are at the moment the world market and innovation leader for ceramic 3D printing. Our company offers the full solution, so it starts from the 3D printers of ceramics and ends with the customized solutions for like software, materials, everything around. And of course, the materials you can print with our printers, as well as the software that the printers can work and document everything you need. Then we have the quality management system right now with ISO 9001 2015, and we are in the ISO 13485 certification process in 2022 right now. At the moment, we have more than 120 employees in 4 different locations. We have 2 offices in Austria and Vienna, 1 in China and 1 in the USA. And we sold more than 100 machines worldwide until today, and 25% of our customers have 2 or more machines, which is something we are really proud of because it shows us that collaboration works really well. Yeah, so this is a short overview about our company history. So we started in 2006, started development of the production or the technology at the Technical University of Vienna. In 2011, we were founded as a spin-off of the Technical University. 2012, we sold our first machines, and since 2019, we are in the dental ceramic 3D printing, and since 2020, we have the material 3D printing, multi-material 3D printing as well, which I will tell you something about later in my presentation. So now here are some reference customers of us. So you can see here from a short insight of our industry customers as well as R&D institutes. With all of these company logos you can see here with the yellow dot in the edge. These are the medical or dental ones, to name a few, just like Careless Mating, for example, or Autobaltic. These are different industry customers, and of course we have many research institutes like the University Heidelberg or the University of Zurich. Yeah, so our technologies, the LCM comes from lithography-based ceramic manufacturing, and this is our process chain. So it starts with a CAD design, an STL file, I think every one of us knows, and our printer slices this file afterwards and build it up with a player until you get the green body. And when this process is over and you got your green body, you have the debinding and sinter step, and then you get your final product in the end. Yeah. So here's the process chain, especially for the dental field. So you can see in the first step that here are just a teeth model here, what you want to print. In the second step is the printing step, where you can see how it looks like if you put it with our software on our 3D printing platform, on the support structure in this case. Then you have like the cleaning, removing of the support, and the sintering. And then you could do the finishing if you want, like colorize or stain it if you want. And in the end, you have like the final product, which you can use. So this is the principle how our system works. So you have like your 3D module, as I told you, and our software slices this into the images. And then we have a projection system which lighten up this mask you have from the 2D image you have on the bottom. So all the white things you can see on this infograph is like the area which gets hard because of the polymerization, because we have photosensitive materials inside of our slurries. So this is how our machines looks from the inside. So we have like in number 1 is our building platform. Number 2 is our bed, which rotates to get a new layer after printing one layer. And then we have 3 the optical system, and on the 4th part, our LED, which so our because of the photosensitive areas we just use blue light here, and we don't need a laser or anything around. And this LED is just one and similar blue light LED as every one of us knows. Yes, and this is how it works. So the building platform comes down and dips into the bed, and then the LED helps to produce shine on the bottom of the bed with our optical system. Then the layer gets hard and the building platform comes up again. A new layer will be there on the bed, and then these are layer per layer how our machine built up the green. When you have this step over, you have like the debinding and sinter step. So you have after the fabrication, you can see here on the left side, the biggest part, and this is a combination of the ceramic particles and the photopolymer. So you can see here that you have like something inside, which is our like the photosensitive contains, for example. And then you have like the debinding step where all of these organics and photosensitive things get burned out of the part. So it's a bit smaller than the first one. And afterwards you have like the sintering step, and all the ceramic particles shrink together, that you have like the dense part, which is only ceramic. Yes, so these are our industrial printers right now. So our like product portfolio, I would call it. It starts with the CeraFab Lab L30. So this is our entrance machine, especially for R&D and universities. So it's just like to get a feeling for the solution, for the technique we use here, and also for some testing and everything around. Then we have our CeraFab system series, which depends on S25, S65, and S230. And these 3 are like our working horses. So you can produce like serial production here. You can use this for industry. You can produce all the materials with no problem we have here, and it's just like for this real serial production, I would say. In the end, we have the multi-material 3D printing, which is where we can combine different materials, but I will tell you something about later. So our material portfolio. So you can see here different parts made of our different materials. Started with alumina, of course, and standard ceramic material, I think, for the industry, but as well for bioinert implants in the medical or dentistry. Then we have the zirconia, which is really, also really common in the dental area, I would say. The toughened parts, like alumina toughened zirconia or zirconia toughened alumina, which are like the mixture of the different materials, depending on how big the part of the zirconia or the alumina in the material is, which is at the research stage right now. Then we have silicon nitride, which is really interesting for the industry, but for the medical field as well, because it has like an antibacterial properties, and you can also have like a microstructure on the material, which is like naturally there. Where we have like microneedles on it to that the body can grow in better, so that bones can grow in better, for example, which is like really nice because you don't need like a rough surface or everything to like increase the bone growing. Then you have our bone replacement material like tricalcium phosphate or hydroxyapatite, which are like both bioresorbable. Silica-based material, which are a bit more in the industry and the casting course field. And of course, all these materials with the stars here in the edge are like on, say, research mode right now. So here you have like a comparison between 3D printing and conventional methods. So you can see here results. If you compare the LCM technology, so printed with one of our machines, compared to isopress. So it's like isopressing is like a much more common technology than LCM. But you can see that the results are the same. So we don't have like big differences in the numbers or in the tests we did. It's like everything the same, the bioaxial bending strength, the hardness, and the density. So here are just some material properties. We have like lithium oxide, our alumina, where you can see the 4-point bending strength here is about 430 megapascal. Then the zirconia in the middle, which is 935 megapascal, and the lithium, which is 760 megapascal. Of course, you can find much more information sheets about our materials and slurry data sheets on our homepage if you want a bit more information. Yes, so our bone replacements. So we have, like, as I told you, they are bioresorbable and osteoconductive ones. So let's start with tricalcium phosphate. This is the white one, and hydroxyapatite, which is in the blue one here in the picture. And we also can produce bioactive glasses if it's needed. All of these materials are compliant with ASTM standards for implants, so you can don't have to prove anything. If you buy it, you just can certify it and start to produce it. Then our newest material, the lithium disilicate. Lithium disilicate is a glass ceramic for the dental restorations, and you have here the highest aesthetics because of the high translucency of the material, and in the front teeth area, it's like really pretty to have lithium disilicates. To use lithium disilicate, we have a really good mechanical bending strength, and it's of course biocompatible and easy to colorize because you have the good material structure and surface. Yeah, some of our solutions and success stories. So, for example, you can use our printer to produce pharmaceutical production. So you can see here, and this was a cylinder made of a lattice structure, and how the holes were. So we have like struts made of 50 to 85 micrometers and openings which are between 100 and 120 micrometers. Then we have bioresorbable cranial implants. So if you can see the picture, for example, it could happen in car accident. Afterwards, you have like a really big defect in your cranial head bone, and then you need, of course, a solution for this. So you can print, if it's not that big, you can print, of course, a bioresorbable cranial implant, and then you can see here it fills in patient specific because it's 3D printed, and afterwards the patient looks like this. Of course, if you have like a bit bigger bone defects, the bioresorbable material will maybe not the material you want to go with. So we can start with other ones, which I tell you a bit later. So the bioresorbable cranial implants, hydroxyapatite is like as natural bone. So you have a patient-specific design, of course, because we have like nearly design freedom with 3D printing. We have an open interconnected pore network, which you can't do with any other solution. And you have like really the size you want to have from the pores, and all of them are connected in together. So this is something you can also only do with our technology, and we have many many studies where we found out which is the best pore size, which are the best connecting things, and how the material grows in the fastest way. Then we have the defined pore geometry, as I told you, and of course it's osteoconductive. So if the bone defect is a bit bigger, maybe you will go for permanent cranial implants. Normally at the moment, most of them are done with titanium, but it looks, for example, like this. Then you have want to go on a holiday with your girlfriend or with your boyfriend, and you want to sit in the sun and enjoy your holidays, but you can't do so because titanium, this is how our head is built up, because titanium is really heat conductive. So your brain, if I can say so, will be like really, really hot as grilled because you have no screen or anything on your head. If you want to avoid something like this, you just can use zirconia, for example. So this is, for example, and how it would look like if you had zirconia inside here. Zirconia has really high strength. You have like a good biocompatibility, and it's low thermal conductive, and you don't need any screens or anything to save your head when you want to go outside or want to go on a nice holiday. This is also a nice application and temporomandibular joint. So you see here how the defect looks like. And then we got the STL model, which you can see here, and this is how we printed. Because this is a really like risky area, we had to polish the parts afterwards, and this is how the parts look after polishing. So this was our surface then, and we had absolutely no problem to implant it in and use it for the human jaw. So here you can see the combination of our best two applications. We call it the combination, the best of both worlds. So in jawbone implant, you have here like a big bone size defect where the bone cannot grow together by itself. So you need something in between. At the moment, most of the time it will be used autologous bone, so bone from inside of the human body. And when you use autologous bone, you just have to cut bone of an healthy area in your body, maybe a humerus or something like that, and implant it in another area where you have the big size defect. So you have here like the double chance to have infections and risk something, because of course you have two surgeries, but you don't need it. If you print it, for example, of bioresorbable materials, so you can see here, you just like have 50% of the risk to have infections when you use this. So you have like the bioresorbable material, in this case hydroxyapatite, to let the bone grow together. But of course you need your jaw to eat something, for example, and that's the reason why you have like need the strength around it. So this is the reason why we put the zirconia cage around this application, for example. So, and then of course, all different ways of dental restoration. So start with crowns, bridges, veneers, whatever. With our technology, you can print like the finest edges, the sharpest fissures, the highest aesthetics, and of course, we have a really good mechanical strength, and we can print like 3Y or 4Y zirconia or lithium disilicate, as I told you before. The solution for aesthetics, so 3D printed lithium disilicate. We have here ultra thin veneers, which you can see here in the picture is implemented together with the Charité in Berlin. And you can see how nice it looks and how good it is for the human jaw. Then we have implanted the retained crowns, which you can see here, which is also a really, really good result. And of course, it's established for glazing and staining. And we have really aesthetic results, as you can see here on the pictures. Also a good fit and precision. Both of these studies you can find on our homepage. And of course, if you have any questions, I can send it to you as well with the whole results, but these are the result pictures. So then you can, of course, print dental implants. So we have like various materials like zirconia, alumina, or silicon nitride. We have a great design freedom, the surface can be tailored, and we are really highly productive, which I can show you later on. And we can print the inner threads together with the whole implant, so you don't need anything to do afterwards. So you can see here, it depends on which different material you want to use. As you can see here, the silicon nitride, the picture on the right edge, you can see here that the microneedles I told you about a bit before, this is like the surface which helps the bone to grow, to take the material better in it and grow better in. So now a bit about our productivity. So we have like the productivity of the LCM process for dental implants in this case, yeah. So we can produce with only one of our S65 medical machines nearly 260,000 implants per year. We have here on the right side the building platform, how it will look like. We can nearly print 200 implants per run, which comes down to 2 minutes per implant, which is a half gram of material per implant. And we have like nearly 260,000 implants produced per year with only one of our machines. So it's like really well for serial production. So last but not least, about our multi-material printing. So with our multi-material printing, you can combine different materials. So you have here, for example, ceramic and ceramic combined. In this case, you can see here the combination of alumina and ZTA. In the middle, you can see here ceramic and polymers. In this case, alumina and polymers. For example, this is really interesting because you can print in a dental area your, I don't know, dental restoration, for example, and you can print the dental restoration made of zirconia, and the support structure you need around maybe of polymers. And when you have like the post-processing with debinding and sintering, you can like just burn the polymers away. So you don't need to cut it off or just have anything about it in the post-processing here. And then we have ceramic and metal. In this case, it's ceramic, zirconia and stainless steel combined in the last picture. So we have here the different things how you can combine these materials. So for example, in graphic A, you can see two materials in one layer. Graphic B is a dense material with a secondary and porous material combined. For example, zirconia and hydroxyapatite as the example before. Then we have on C2 or multi-phase materials with a gradual variation in material composition, and D, a gradual variation in both density and the materials. So you also can print here different color stains or anything that you have like nice colors and different colors in one part. So here you can see also some examples, the alumina and the zirconia combined here. And on the right picture, you can see that how sharp the border between alumina and ZTA is. So there is nothing like no pollution from the other material on the other side. And this is how good our multi-material printing works. So last but not least here, we have the best of both worlds. So we have like the bioresorbable material and the zirconia, as I told you before. In this case, both of them are printed simultaneously. So they are printed at the same time and with only one print run. So you don't need to change any material or anything around it. You just can start it and get a part out of it with two different materials here. Yeah, so come to an end. We are your partner in ceramic 3D printing. We have like CeraFab Medical Systems in the US, Europe, Brazil, and Australia at the moment. We have CE certifications for medical devices class 3 and FDA approved medical devices class 2 already in the market by customers. We have the material production, which will be under ISO 13485 QMS. And we are with our bone replacement materials and our bioinert materials, of course, with customer projects into the human body since 2017. Yeah, so thank you for your attention, and please feel free to contact me if you have any questions. Yeah, we'll be happy to help you. Thank you.
Thank you very much for sharing with us this new innovation in your materials and in your 3D printers. Some question about this is possible to have multi-colors and different translucency with the lithium disilicate. Also, this is interesting for the dental business, the lithium disilicate.
So we are working on the different colors, and with the multi-material machine, it of course should be possible to combine the different colors. At the moment, we only have one type of translucency, but of course, it depends on the colors, how much you can see this translucency and how translucent the part is in the end. So I think if you combine like an lighter material, like an A2, for example, with an A3, you can like see also different in translucency because one is a bit darker and one is a bit lighter.
Super. And there is also a new research and development, some Swiss company like Methods about to produce alumina toughened zirconia that reach about 1,200.
You aren't, I think you muted yourself. I can't hear you anymore.
1,200 megapascal.
Yeah. Yes, so we have like a big collaboration together with Methods, and we are working on this, of course, and also create our ZTA and ATZ to a final product at the moment together with them. So yeah. that should be possible in the future, but we are like in developing state right now, so I don't have like that fixed numbers at the moment for the strength.
Super. For the metal, that's possible to print in the same printer from Litho's, or we need something from Incos to make multi-layers metal and ceramic?
No, as I showed you, the multi-material printer, you can only use Litho's materials. So we can combine here the different ones in one printer together in the same print run, because you have in this machine just 2 vats and a cleaning system in between to have like the no pollution from the different materials. And this is how it works. Yeah.
We are very interesting about to implant these systems in the dental business. So we are interesting also to see more samples about final result, how it looks in the in vivo, in vitro, everything in the real cases. So I will check about these studies, and we can share it for all interesting about the new technology of lithium disilicate and the implant production lines in the dental business. Thank you for your sharing with us all this information, and we are happy to invite you in the future about also new innovation in the technology of 3D printer. Thank you.
Thank you very much. Thank you for having me. Have a nice day.
Have a nice day. Have a nice evening. Bye-bye.